on African easterly waves, which is obviously something that, as an East Coaster, the systems that come from those seedlings, being tropical cyclones, are a pretty important thing to our surf, especially during the summer and fall months. I started Surfline in 2005, and I primarily forecast for the East Coast. There are times that I go and am on site for events, and this is actually an example of that. I was at the Billabong Pro Tahiti a couple years ago, and was on site there to do some decision support with KP. That's Kieran Perot there on my left, and that's actually I think the last event that Kelly Slater won. So that was pretty awesome to be in the channel when that happened. I think you defeated John in the final, so pretty special. In addition to that, I was chosen to be the official forecaster for the 2020 Tokyo Olympics. It's at Shida Beach outside of Tokyo. Of course, that's been postponed until next year, so we have an extra year to stress about that, and hopefully they get some waves. Switching over to Surfline, we were founded actually in 1985, so we are old. We are approaching 35 years. Actually, it's going to be this summer to be 35 years. We're a global company. We have offices in California, which is our headquarters in Huntington Beach. We also have an office here in North Carolina on the Outer Banks. We also have an office in the UK and over in Australia. Our East Coast team, though, is in a mix of Florida, North Carolina, Jersey, and New York. You can see some of the forecasters there in the photo. That's in our Huntington Beach office. As a company as a whole, we have 100 employees, just about. 12 of us are meteorologists that work on the forecast team. We have 6 wave modelers and science engineers that help basically run our models and help improve our overall accuracy and help validate our forecast and that sort of thing to try to improve. We also have 7 cam operations team members and a ton of vendors that help us with our over 750 cams that we have around the world. We have over 160 on the East Coast, Gulf Coast, and Caribbean combined. So pretty extensive network of cameras, and man, they've come a long way since I started. I remember them just being like a frame a second, and trying to understand what the surf was like from that was incredibly painful. So it's pretty amazing how far that technology has come. We also have relationships not only with the public and with our users, but also government agencies, academia, and also the media. We have partnerships with people like the Weather Channel, CNN, USA Today, and all those things where they basically show our syndicated cam streams, and also we send them some information as far as swell and marine forecasting as the situation makes it necessary. Before we dive into actual surf forecasting, I think it is important to discuss, why the heck do we have weather? Why does that even happen? Well, thankfully for us as surfers, and for me, for my employment, we do have weather, and the reason is the sun, pretty much. As your solar radiation comes in, it heats the Earth at a different rate, depending on how straight on those rays come. Typically, your tropics, you're going to get the most amount of sunlight, so they're going to be the warmest. And then up north, as you get closer to the poles, you get colder. The key here is the fact that the atmosphere doesn't like that. The atmosphere wants to be stable. It wants everything to be the same temperature throughout the whole globe, but that doesn't occur because you constantly have this injection of sunlight. That difference is what drives our weather, pretty much. The atmosphere trying to come to a state of equilibrium. And then within that, the pressure gradients that we get are what leads to actual winds developing. And thankfully, we have wind, because that's what we need to make swell. And basically, all wind is the transfer of energy from the atmosphere into the ocean. And there's 3 factors that we look at to determine how much swell is going to be generated. So first of all, it's wind speed. So you need stronger winds to produce bigger surf. Wind duration. So not only does it need to be strong, but it needs to happen over a decent amount of time. If you have only a short little burst, like you could even, I guess here we actually had some water spouts the other day, and those don't produce much surf because there's a significant limit in the duration and also the fetch. And the fetch length or width is the area at which those winds blow over. And this is kind of a little bit of an animation that shows that as those blue arrows indicating the wind blow across that fetch area. You can see the wave height builds as it kind of grows through that fetch zone. So the bigger and wider your fetch, the longer the duration, and the stronger your wind speed, the bigger swell you're going to get. Any of those factors can also be inhibitors to producing swell. But ideally, what you have is you have all those things directed towards you. But if you don't, you can actually see this here. There's a little bit of side energy that comes off of that. So it doesn't have to be directly to you. If you're off on either side of that, a fraction of that energy will also make its way towards your beach. So as we get going here, we'll chat about a couple of key terms. I kind of broke this down here so we can kind of go through each one step by step and kind of build the foundation of surf forecasting, just to make sure that we're all on the same page about what each of these mean and what they mean for us as surfers. So first up, swell height. And it seems like this is incredibly simple. Wow, it's just how big the swell is. But what's crazy is there's actually a lot of mathematics that go into this. So significant wave height is what you commonly see on your buoy plots, or if you go to the National Data Buoy Center and you look at their information, they'll have significant wave height. And what that actually means is it's the mean of the greatest third of the waves passing a single point. Sounds pretty complicated, but actually what they did is they've done a significant amount of studies to determine what a spotter would actually look at the ocean and say is the significant wave height of that. So it's kind of based on a mix of history and science, and then also a bunch of observational stuff. So pretty complicated. I'm not going to get into it too much. As surfers though, that value really strictly as a number, your significant wave height, doesn't really tell you everything you need to know in order to know whether there's going to be waves or not. Which brings in another one of the factors that we look at, and that's swell period. So swell period is basically the time it takes. Let's say you're sitting on your board and a wave comes in, you decide not to paddle or catch it, and you float over top of it, and then you float down, and then another wave comes and it's small too, and you decide to float over that one again. The time that passed between you floating over those two is basically your swell period, and that's typically measured in seconds. Swell period is also very complicated. The longer the period that you have, so you think about a swell that's 15 seconds, 17 seconds, 20 seconds, or whatever you may have, the deeper into the ocean that energy extends. And what that basically means is that there's been more energy that's been transferred from the atmosphere into the ocean. As we can see on this graphic, pretty much if you have a 40 knot sustained wind over a certain fetch length, you can see that the energy grows, the wave height grows, and the depth at which that energy extends down into the ocean also grows. Now this, for us on the East Coast, is something that comes into play, especially when we have longer period swells like hurricane swells, because that wave energy does extend so far down into the ocean that when it gets into our continental shelf, into our kind of closer nearshore waters, and the depths are relatively shallow, you see a significant amount of decay due to the frictional effects of that incoming swell. So basically, if you were to look at the 120-mile buoy off of Florida, the East Canaveral buoy, and then compare that with the regular Canaveral buoy, you'll see a significant drop in size from one to the other, and that's because of those frictional effects that are occurring within that near shore environment. How far does that extend down? Well, basically what you do is you take your period, you square it, and then you multiply it by 2.56. Not something that I can do at the top of my head. I also thought it was kind of interesting to discuss the swell period and how that interacts with our different beach breaks. In typical, you'll hear, oh, wow, longer period, it's gonna, our beaches are gonna be closeouts and it's just gonna be one block long, dumpy closeout. And for a lot of zones, that can be the case. If the angle at which the swell is coming in is basically square to your beach, and there's nothing there to kind of break up that swell, yes, like a lot of times you will have just closeouts. So typically at those locations, you want shorter period energy, which we would say is anything on the Outer Banks. We a lot of times say it's got to be less than 13 seconds. If 13 seconds or above, you start to get closeouts, and it'll break out on our outer sandbars and just do some weird stuff. Another thing that you can do, and actually this happens on the West Coast a good amount, is you get another swell to cross up or break up those longer period lines. So if you think about like a south swell in Newport or Huntington Beach, and you get a little bit of northwest wind swell to mix in with a long period south, you get these nice bully lefts and rights that's just pretty magical. A lot of times longer period swells are optimized by points and reefs. So this is actually a picture of Point Judith, which is up in Rhode Island during Hurricane Bill, which was 2009. That was a pretty significant Category 4 hurricane that took a pretty typical track and sent some pretty long period swell up there into the northeastern U.S. And you can see a lot of people surfing in pretty good shape too. So it's a good example of a spot that likes longer period energy. Swell direction, and actually this is the same as wind direction, is a common question that people have. I actually taught a intro to meteorology course when I was at NC State, and a lot of my students had a hard time understanding wind direction, and I'm sure swell direction is a confusing thing as well. But basically, if we say a northeast swell, that means it's coming from the northeast and traveling to the southwest. Same thing with your wind direction. Northeast wind would be onshore for many places along the East Coast, and but not UBEF, actually. That's offshore down there along the Crystal Coast. But yeah, so basically 90 degrees is due east, 0 or 360 is north, 180 south, 270 is west. So definitely a little complicated, especially if you're not used to it. But the key to remember there is it's where the wind or swell is coming from is how we say that as surfers and meteorologists. Oceanographers, totally different, but they're kind of outcast, so we don't really listen to them. Swell decay. So basically, we have all those variables that are in place. You have this storm, as we can see here in this graphic. It's blowing over a certain distance. It's you have your fetch length, you have everything set, and then now it's time for that actual swell that's been developed to leave that storm and propagate to your coast. Well, the first thing to remember is swell is a conserved quantity. Swell period is a conserved quantity. So basically what that means is if a 12-second swell leaves that storm, it will be 12 seconds when it arrives at your beach. It doesn't actually grow in length, that actual individual swell. What does happen is the longer period swell energy that is in there will travel faster than the shorter period swell. So you see longer period energy first, and then your swell periods will gradually drop as the swell hits your area. You see your greatest decay in the first 1,000 miles after leaving a fetch. So pretty much right when it's done developing, you see a pretty quick drop off there in your in the amount of size because that shorter period energy does drop out. And I think many of us here on the East Coast are familiar with the idea that when you have offshore winds that are meeting that shorter period wind swell, it drops very quickly. And there's a combination of reasons why. One of it is because it's no longer in that fetch region because now the wind is offshore. And also because you have interactions between those waves that are causing it to quickly dissipate. And that's why a lot of times when the wind switches, you definitely want to be on it because it'll drop pretty quick. In contrast to that, if you go over to a place like Nicaragua where you have consistent winds that are coming off Lake Nicaragua and blowing offshore, it has very little impact on the longer period swell energy that's coming from the South Pacific because there's not much interaction between that longer period energy, which has most of its energy down in the water, like we saw a couple slides back, and it's less impacted by those opposing winds. All right, this one hits home for me directly, is the wind swell versus swell, and even you know, some people use the term ground swell. So basically what it is wind swell is not related to what your swell period is. So if it's 6 seconds, it's not necessarily wind swell. Wind swell is what you call things that are still developing within that fetch. So once it leaves that fetch, it is no longer wind swell, even if it's 6 seconds or 12 seconds or 18 seconds. It immediately becomes swell once it stops being generated. So kind of a technical thing, but you know, I hear that a good amount of, you know, wind swells less than 14 seconds or something like that, and that's not necessarily the case. Technically and scientifically, it is just related to whether it's still developing or if it is moved away from its generation area. So a little complicated. That's kind of me being a little bit of a nerd and picky, but it is what it is. Something that impacts our surf on the East Coast a good amount, and actually pretty much everywhere that doesn't have like a dominant trade wind flow, are your land and sea breezes, especially during the summer months. This is a nice little graphic I found here on the right that kind of shows the general pattern that's happening, but pretty much air it's easier to heat up than it is water. And that's why right now our water temperatures are still pretty chilly up here on the northern half of the East Coast, but our air temperatures can warm up, you know, one day up to 70 or 80 or whatever, and the water stays 48 degrees or whatever it is in your area. And that's because it's basically easier to heat the air than it is and the water. There's a variety of reasons behind that, but we won't get too deep into the meteorology there. But pretty much for the sea breeze, as the air warms over the land, you end up getting a small circulation, and that turns the winds onshore as you have the heating of the day, because you have that discrepancy between the cooler water and the warmer land. As the sun sets and the temperature over land drops, again, because it's able to quicker, you see that flow reverse, and you actually get offshore flow during the mornings, which we call a land breeze. So pretty cool pattern. It's really interesting, and there's a lot of variables that go into that. Obviously, you've seen instances where one zone may stay offshore longer than others, and a lot of it is dependent on the shape of your coastline and nearby thunderstorm activity and several other factors. But in general, this is the schematic of kind of what goes down. Another question that I get a lot is, why does the East Coast have so many more waves or bigger waves than the East Coast? Specifically for Southern California or California, or any of the coastlines that face there through the Americas, you have great exposure to both the North Pacific and the South Pacific. So regardless of season, in that the biggest basin that we have, there's going to be a storm somewhere that has the potential to send you waves. Whereas on the East Coast, we have a variety of things that can restrict our swell windows, whether that's Bahamas down in parts of Florida. If you're in the southeastern U.S., you're blocked by the Outer Banks. Sorry. And then we don't have very good exposure to the South Atlantic, but we do for certain locations, especially the northern half of the East Coast. We have a pretty large continental shelf for a good portion of the East Coast, as we can see here on this Google Earth image. The continental shelf on the western fringes of continents is significantly smaller, so we see less decay as the swell comes into those zones. It basically immediately hits the coast. And it's the same thing for Hawaii. Hawaii is super deep offshore, and there's very little time or any kind of bathymetry that reduces the amount of energy that's going to actually hit the beach when it does. But here on the East Coast, we have a pretty large continental shelf. You can see two zones that are a little bit of an outlier are the Outer Banks. We actually have a relatively small offshore continental shelf here. And then actually down into parts of southern Florida, you actually have pretty deep water that's right there off the coast of Palm Beach and zones there. But of course, as you get down in there, you're having blockage from the Bahamas to the east. And then probably the biggest one is your dominant storm track. So this is actually a satellite image from yesterday, but pretty much you typically have west to east movement, the so-called westerlies, moving across. And those storms that form, again, going back to our three factors that determine how much swell is being generated, really the strongest winds within those storms, the longest fetch lengths, and also the longest duration because of the storm movement is all favoring those breaks that are on the western side of continents, because that's how our normal flow goes. A situation like this, strongest winds are going to be pointing away from us. The duration that the winds that are directed towards us would be relatively small and short-lived, and that limits the amount of swell that ends up getting sent back to us, very unfortunately. Obviously, one big difference here from this normal pattern is when we get tropical systems, because they're far enough south, they're able to move from east to west, and a lot of times that's when we see some of our biggest swells over the course of the year. That, or when we actually get one of these storms that kind of sit still and send a swell back, which we've had a few of this winter. I wanted to touch on a couple of zones on the East Coast that are kind of favored as far as consistency in swell and also size. And it's actually interesting, these coincide. We were talking about, the Easterns is held on the Outer Banks, traditionally down at the Lighthouse, but more recently at Jeanette's Pier. And I think every year I can think of, there's waves. It seems like September is a great time of year for us surf-wise. You have a combination of tropical activity, you can have frontal activity, and it seems like we pretty much always have waves. So it's a great time of year. But here on the Outer Banks, we have exposure to everything to short period northerly wind swells. Today, we actually had a little north wind situation blow down the coast and produced a little bit of wind swell for us. And even if you're down in Frisco, we're exposed to southwesterly wind swells. So you have a wide window, depending on your location, within a relatively short distance that's exposed to a good amount of directions. And we can also handle a good amount of wind directions. Everything from south is not too bad if you're up into the northern parts of the Outer Banks. And then we can handle even northeast down on the south-facing beaches around Frisco and Hatters Village, as long as they're not too strong. We also have that small continental shelf, so any kind of swell that is coming into us is not really decayed as much as what it would be up in Virginia Beach or even spots to our south. And then we kind of have a pretty cool location in relation to the storm track. So we're close enough to things that are pushing up in the Northwest Atlantic where we can get swell down to us before it decays too much and gets small. We have nice southerly swell exposure. And then anything coming out of the southeast or east southeast, we pick out pretty well, especially down on Hatteras Island. So, and then this is actually a swell ruler that shows our exposure down to the South Atlantic. So the past couple summers, we've actually gotten a few Southern Hemisphere swells here on the Outer Banks, and those are pretty cool because they last several days. We had one, I believe it was not last year, but the year before, that lasted, I think, 7 or 8 days. We had rideable waves through the month of July. Here on the Outer Banks, and it peaked. There was actually some chest even head high waves during the peak of that swell, which is pretty impressive because, as you can see here, it's traveled basically 6,800 miles to get to our coastline. It was also one of the swells that Brett surfed in Skeleton Bay, which is also kind of interesting, but pretty cool stuff, at least to me. Standout zones, again, we'll look at New Jersey. Pretty unique bathymetry there. You have some cool offshore field features like the Hudson Canyon that's offshore that can help funnel in longer period energy out of the southeast or east, depending on the exact direction and period. Also, you have all those jetties that line the coast that just break up. And gosh, if you see a south swell in New Jersey with west winds, it's just magical. I mean, as a regular foot, it's a great thing to see, and it's a pretty special situation if you can tag up and get some of those. Also see a variety of wind and swell combinations that work here. So similar to the Outer Banks, where we kind of have, if you have a north wind, you have a place to go. Well, for New Jersey, if it's blowing southwest, you can head north. If it's blowing northwest, you can head south. And then also with the variety of different types of weather that we see, we have a pretty open window to kind of get several different things to provide some surf with us, which is a pretty cool situation there. Further down into Florida, one spot I wanted to focus on here was New Smyrna Beach, down there by the inlet. Just an incredible small wave magnet. People ask me where the most consistent wave is on the East Coast, and excuse me, as far as rideable surf, I would be hard pressed to think of another location other than New Smyrna Beach. It seems like there's pretty much always something to ride on, some sort of equipment there. So incredibly consistent. And also you have some unique bathymetry that goes on here, not only for New Smyrna, you have a couple shipwrecks there, you have some interesting sand features and stuff that are going on offshore. But even as you head further south in the RCs, there's a certain spot on Northeast Swells. South Florida also has some really interesting stuff going on. And then, sorry, let me grab a little drink of water here. Maybe take a breath and have a period at the end of one of these sentences. Thank you. We have trade swells. So basically a trade swell is generated from your trade winds, which are pretty typical, blowing across the Caribbean on the south side of your Atlantic ridge. And that can keep some rideable waves north of the Bahamas and keep some surf in the water, which is always a welcome sight down there. Tropical swells, a big one, but obviously not something you can really depend on. But when they do occur, you can get some really great waves down there. Wind swell events, you get post-frontal northeast wind swells. Can get rideable surf, again, maybe not the best conditions, but definitely some waves. And then when you have those northeast systems that set up off of the Northwest Atlantic, they can send down some pretty longer period northeast swells, and those can provide some great surf to us. Another one that's really crucial is if we get lows kind of off the southeast coast, because you can really open up some spots down into South Florida and kind of sneak that swell down in between the Florida coast and the Bahamas, and get some good waves all the way down to South Beach, which is actually the situation that we saw on that first Camp Rewind we had to open things up here. I wanted to look at a real-time example and kind of maybe go through what I deal with on a day-to-day basis, and then kind of give a little bit of insight on some of the buoy observations and how to maybe read those a little more in depth, like we do here with Surfline at the team. So pretty much what we have is, so this is a hurricane force low that we had that pushed off the Outer Banks over the weekend. Actually brought some pretty severe weather here. We had gusts up to close to 70 miles an hour over the weekend. But the system strengthened into a hurricane force low there just south of Nova Scotia. Pretty classic satellite imagery that you can see. And on the right is one of the tools that we have behind the scenes. It's a satellite that goes around and actually remote senses the wave heights that are occurring across the globe. So in this instance, the red is a Swell model and the green is the observation. And pretty much you can see that there's a more than a 10-foot difference between what the satellite actually sees and what the model said was happening. So as a forecaster, I look at this and I know that the storm is outproducing the models are saying. And that really throws up a flag to me to know that I got to pay extra close attention to this because something interesting is going on and the models aren't right. I got to dig a little deeper and try to figure out what happened. So the satellites is basically called altimetry. Very helpful tool for us forecasting because there's not a lot of observations over the ocean. So anything you can get your hands on, like a great satellite pass like this, really helps you understand what the heck's going on out there over the open ocean. Don't get to take a deep breath. This is something I look at every day, but it's again a satellite derived product where pretty much the satellite goes over the ocean and can tell you what the wind speeds are. Which thank goodness we have this because we're able to verify our models and see how things are doing compared to the observations. So this is that system that we were looking at more zoomed in. If you're looking at the image on the right, those purples with the little flags, each one of those is basically 50 knot winds. And if it has a little flag and a little stick on the side of it, that means 60 knot winds. So you can see there's a wide area of 50 to 60 knot winds on the southern side of this system. Unfortunately for us, those areas show that it's going away from us, not heading back to the East Coast. But of interest is actually the little area just to the north there, those purples and pinks that are heading the opposite direction. And that's actually going to send a little bit of swell back towards the East Coast. So we'll do a little investigating here to see how much of that is actually going to happen. As we've already kind of been aware that this is a scenario that the models aren't doing a great job with. So we'll try to dig a little deeper and see exactly how much swell might be coming back to our beach here. In order to do that, we take a look at some of the satellite observations, but then buoys are the biggest tool that we really have. A lot of them are fairly close to us, so there's not a lot of lead time with the swells that happen. And of course, on the East Coast, a lot of times the weather is on top of you is pretty much what's giving you waves. So there's not a lot of lead time. You compare that to the West Coast where you have a Southern Hemisphere swell that may take 8, 9, 10 days to reach your location. Things are pretty much happening in an instant here, and you really need to be on top of things. But in general, when you look at the National Data Buoy Center or any other website that's out there that you get your swell data from, it will show you a significant wave height and a dominant wave period. And historically, those have been used and produced for mariners because that's their primary concern. How big is are the waves and what's the period? Because obviously the period is really long. You can kind of ride over waves and that sort of thing. If it's short period and choppy, it makes for a much rougher ride if you're in a boat. But actually the buoys that are out there record way more information than just your significant swell height and your dominant period. And that's really good for us because we can use that information to decide whether there are going to be waves or not. So we take a look at the same system. Let's take a look at what the buoy observations had to say today. Great buoy for one of my favorites, if you have a favorite buoy. They're all my favorites, I guess. But the Nantucket buoy, which is just south of the island of Nantucket, south of Cape Cod, a great indicator buoy for northeast swells for us, for the Outer Banks, also the Georges Bank, which is a little bit to the northeast there. Also another good buoy. But basically, if you look at this, there's a location on the top left. We can see the National Data Buoy Center entry here that basically shows let's see if I can move this. There we go. Basically shows a wave height, a significant wave height of around 6 feet at 11 seconds. Now, if this was a deep water swell that was actually impacting your beach and you told me it was 6 feet at 11 seconds, I would predict that the surf would be somewhere between 6 to 8 feet on the face. So what we would call in our Surfline scale, 1 to 3 feet overhead. So pretty solid. And actually You probably bring a different board and, come pretty prepared for that. If we look at Surfline, where we actually take the full swell spectrum and break it down into individual components, we see that actually that number is kind of a little bit of a misnomer. And the reason that is because of how significant swell height is calculated. So what we do is we actually break it into several different swell bands. You can see it's actually around 4 feet at 10 seconds. That's that east-northeast swell that we're really concerned about, because that's what's heading back towards the East Coast. That west-southwest stuff is heading out into the North Atlantic and really not going to be an impact on our local swell. So 4 feet at 10 seconds, more of a head-high-ish wave is what you would expect at a well-exposed break that is seeing that amount of deep water swell. So if we take a look at, again, the buoys here, another thing that we could do is take a look at the past history. Again, the National Data Buoy Center there on the left and our Surfline graphic there on the right. Again, for the Nantucket buoy, which is 44008. Interesting thing to pull out here. I know there's a lot of numbers, but if you look at the image on the left, MWD, the column with, that means mean wave direction. So you see it's east-northeast, east-northeast, and then there's some west, and then east-northeast and some west. You see the swell period, which is DPD, actually bounces around some between 7 and 11 seconds as well. But notice that the 7 is coincided with the west, and the 11 is the east-northeast. Basically what's happening here is the buoy's reading this and bouncing back and forth between what is the dominant swell and which one it should display as the dominant swell. But both of them are actually in the water at the same time. So this is something that you can kind of miss if you just glance at the buoys and say, oh, it's 5.2 feet, 7 seconds out of the west. Like, oh, that's not going to produce anything for me because it's all heading out into the ocean. But then you see that 4.6 at 11, and you think, okay, out of the east-northeast, maybe that is. And I hear, people talking about, well, the buoy just pinged 11 seconds or pinged 13, or it's, the swell's starting to show. And a lot of times, the swell's either been there for hours or days, or and it's just been hiding underneath, the way that the significant wave height and dominant period are calculated. So as an example, on the Surfline image that we have to the right, you can see, actually I got pointed this out here. So we have that 10-second and 7-second energy. And then the direction with the 7-second stuff is out of the west, which is like 270. And then the 10-second east-northeast swell is out of the east-northeast. And that would be what impacts our surf, but it's kind of hidden in the values that are given by the National Data Buoy Center, because that information is really tailored more towards mariners and shipping, and not so much to surfers. But one of the things that we do at Surfline is we do break that energy apart, and we're also in the process of revamping some of our buoy pages so they'll look a little prettier than what we have here. But it's a really powerful tool, and really, I mean, when I wake up in the morning and I want to know what the surf's like, I go and I pull up the buoys and I interrogate them and see the different swells that are in the full spectrum, because a lot of times swells that mean something to us as surfers can be hiding underneath something that means nothing to us. So really investigating those and interrogating that is a very powerful tool, and I am very passionate and excited about doing that, because there's a lot of times you can see things that other people don't see, and you can sneak in and get sessions that other people may not, think nothing's going to happen. There's definitely been lots of times here that I've managed to slip under the radar a little bit and grab a couple of days with nobody out, just because of information like this. So definitely an interesting thing. And I will say, prior to, we have one more slide here, but if you do have any questions, if anybody out there has questions about the buoys, or if in the future you just have general questions from me, I am 100% open. I'd love to share any kind of information or knowledge I have to help you get waves, because again, like I said at the beginning, that's the whole point. The whole point is for people to get waves, and that's the cool part about my job, is if people are stoked and happy with surfing, I did a good job, and that's kind of a pretty cool thing to say. So skip to this last slide, and basically what I did is I found an observation of the surf. So this is actually Cape Cod today, from Cape Cod Surf on Instagram. They're a great follow. Some cold water up there, but yeah, So basically, we said that it was 4 feet at 10 seconds would be around head high, and that guy seems to be pretty excited about it. So that's kind of in a nutshell what we work to do and how we do it. And we do it for the whole East Coast and the Gulf Coast and the Caribbean and everywhere around the world, really. So I think with that, I will open it up to questions, and yeah, let me know what you got. Are you still there?
I'm still here.
Okay. Actually, I did have this one more slide. I included this. This is a video of the USS Kitty Hawk, which is a 1,000-foot long carrier in the West Pacific a couple of years ago. So the deck is 40 feet up, and this is in a storm where we estimated, say, 35 to 45-foot seas, winds in the 40 to 50 knot range. And basically a storm like this, we would expect it to send swell 4,000 miles away. If that was your break, it would be basically 8 to 12-foot waves, 6 to 10-foot waves, 5,000 feet away. So I thought that was kind of cool to actually see. You can look at it from a satellite, but to be right there in it and see kind of what that means is pretty crazy.
That's pretty cool. There are some questions coming up
okay.
down there. But before you answer them, can you remember the question I asked you earlier today? And I think it's important for everybody to know, because we look at Surfline and we look at the regional forecast and we look at the premium forecast that goes on for advanced. Can you explain again how you get those numbers? Which ones are manual that you put in from you doing your research, and which ones are automatically generated?
Definitely. Yeah, here I can, how about I close this out and I can pull up I'll go to, actually, I wanted to pull this up because, let me refresh my page here. This is actually the Olympic site right now. We have a couple cams over there. And Sheeta is actually pumping today. So it's a shame that we're not there. But so let me navigate to a couple different places here. So you can go to a cam that's right by my house here at First Street, Kettleville Hills. So pretty much, if you're on this page, the actual wave height and condition rating that's here in the colors are produced by our team of forecasters. We do that. We actually have several spotters up and down the East Coast that provide us with observations of what the waves are like. And then we combine that and make it into a wave height and condition rating for breaks all up and down the East Coast. We do this twice a day, every single day of the year. So we will do this dawn patrol, and then usually between 12 and 1 o'clock in the afternoon, those are updated. Obviously, we're in the midst of the COVID-19 pandemic, but typically what you would see here is a surf report and a short-term forecast. And basically what that is that's generated by our forecast team to say what the surf's currently like, and then also what we expect over the remainder of the day. The data that's further down the page here is actually model driven. But we do have that science team that goes in and tweaks things. So when we get feedback from our users that something's inaccurate, we can go in behind the scenes and change that. But on a day-to-day basis, that kind of runs on its own. As we shift over to the regional forecast page, this is what we kind of consider our bread and butter as far as our forecast products, is right up here in these colored boxes. So basically what Rob Mitzdifer has done, Rob's from up in Long Beach Island, but now lives here on the Outer Banks. He has deciphered all the swell information, which includes some of these little, the swell graph here, which is model driven, and produced a forecast of wave height and condition ratings for the AM and for the PM, and then gives a little description on kind of some things to worry about here over the course of the day. So the system that moved off today here is actually going to send a little bit of northeast swell back. I'm pretty excited about tomorrow, and you can see that Rob has a waist to shoulder high and a fair to good for our condition rating tomorrow with some decent winds. So looking at a couple of good days actually here for us over the next 7 days, and that's actually how far out we go. So we go out 7 days with these colored forecast boxes. Beyond that, as they turn to gray, that becomes a Lola generated forecast. That's our swell model is Lola. and it actually goes out 17 days. So the first 7 days, those boxes are generated by our team of forecasters, and then beyond that, it defaults to a model. Premium forecast analysis is also another thing that our forecast team generates. Typically, these are done 7 days a week. We've pulled back a little bit on that just because of some of the stay-at-home orders and some of the guidance from local municipalities on social gathering and that sort of thing. But I actually did it today. So we basically go through and do a weather outbreak or weather overview of all the different things. Here's the satellite imagery. This is the system that's going to be sending waves to us on the Outer Banks tomorrow. And then I discussed the fact that actually pretty impressively, we have 5 systems that we're going to be watching over the next 10 days to provide us surf, primarily for us north, but pretty interesting pattern we have, especially considering it's the end of April, when things normally are kind of starting to slow down now. Then we'll break into a swell outlook and then also kind of a longer range thing. One interesting note that I was thinking today was actually, so the hurricane season officially starts June 1st, but actually the past 5 years, we've seen a tropical system or a subtropical system develop prior to that. So based on that and the fact that we have above average water temperatures off the southeastern US and Florida coastlines, and then also in the Gulf of Mexico, it would not surprise me in the least to have one or maybe even 2 systems pop up for the official beginning of the hurricane season on June 1st. So on a day-to-day basis, that's kind of what our forecast team is doing. We're producing those reports, those observations. We're doing 7-day forecast boxes and then this premium analysis. Oh boy, and I had a lot of questions. Let's see, I'll go through this here. I have a Caitlin Kane. Which buoys are good for Fenway and Narragansett in Rhode Island? A couple of ones. So you take a look at the Block Island buoy, which is a good one that's offshore there. I was checking out that one today. It was kind of interesting because Rhode Island, if you are unfamiliar with it, the coastline is very varying. It faces a lot of different directions. You have a lot of different nooks and crannies. Wind and swell combinations are pretty extensive for it being as small of a coastline as it is. So swell direction and wind direction are incredibly important up there. And Block Island is a good one to look at to see that swell as it kind of still out in deeper water. Further out, it depends on kind of your swell direction. You could look at the Nantucket buoy or the Georges Bank for any kind of easterly direction that could get into a couple of different spots there. Further south, you'd probably be watching the Texas Tower buoy. Back in the day, we would probably be looking at the East Hatteras, but that's been gone due to storms. So probably West Bermuda would be a good one further upstream for any kind of south or southeasterly swell for Narragansett, Rhode Island. We have a question here from Aubrey in ESA in Palm Beach. Why is Fort Pierce flat all summer? It's a great question, actually. And the answer is the Bahamas. So traditionally during the summer months, what you see is a lot of east to east southeast trade swells. And that's due to the winds, like I said, around the Bermuda High that forms. And that keeps some rideable surf up, north of you. The break-off is kind of right around Fort Pierce, depending on exactly how east or east-southeast that swell direction is. If you get more easterly, you can kind of sneak a little bit of it in there. If it goes more east-southeast, you're going to have to head north in order to get a little size and a rideable wave. And we kind of see that gradient a good amount as you head from there up into even Sebastian and parts north up until Melbourne, and especially up into Cocoa Beach, where there can be a little rideable wave there during the summer months, but Fort Pierce will be pretty much flat, unfortunately. All right, moving along here. Let's see, any tools in Surfline that get overlooked that we can look for extra insights if we dig into it? That's a great question. One of the, I feel like one of the things, in addition to the buoys, which I feel are incredibly powerful tool that are not necessarily available at many other locations, we do have a pretty extensive list of charts that's, we both have high resolution winds for a variety of locations. So if looking at tomorrow, you can see we're going to try to see some southwesterly winds try to take shape and increase through the day. It's a great way to visualize, your wind direction and your windows of best conditions. And then some of the advanced charts, which we're working to revamp, are also some powerful tools to look at a variety of kind of deeper power tools, as we kind of like to say. But I would check out the charts page. I feel like it's probably not utilized as much as some of the other sort resources we have on Surfline. Book recommendations. Yes. There are a couple of great books that have been done on swell and surf forecasting. See, I think there's a few by, I believe his name's Tony Butt. Let me look at this really quick. He has written a few books. He actually is, he works for Magic Seaweed, which is owned by our parent company. But Tony Butt has written several books on surf forecasting and that sort of thing. There's also a book, which I might have laying around here. If you just give me just a second, I'll grab it and show you. This is a great book written by one of the original forecasters at Surfline. It's called The Weather Surfer. They're pretty rare, but it's written by Vic Morris and Joe Nelson. So if you're able to find The Weather Surfer, it was written in the late 70s, and it's a great introductory to manually forecasting. So not depending as much on the models or anything that's spit out, but actually how to calculate several of the things that we discussed today by hand. So it's a great read, and it's pretty solid, solid history of kind of where we've come over the past few decades. But if you can't find that, I would look for one of the books by Tony Butt. How much does the tidal flow of the inlet affect the waves at New Smyrna Beach? Let's see. I've personally only surfed New Smyrna a handful of times, but I know that historically the mid and higher tides have kind of been a little bit better there. Obviously, that comes and goes with some of your sand, but anytime you're near an inlet like that, you know, there's definitely some impacts on the wave quality, the wave cleanliness, depending on your winds, and then also the overall shape. You know, if you're looking, I know I can think off the top of my head of some days where, you know, we get that lower tide and kind of start breaking out, you know, where the sharks like to be, and you know, it definitely seems like it kind of comes in and hugs in a little bit better in the mid and higher tides. So I would say, I mean, it definitely has an impact. I know Mike Watson, one of the forecasters for Surfline, that lives down towards the Sebastian Inlet area, talks a lot about you know, the rate of water coming in and out of Sebastian Inlet there. I mean, he's sent videos of people in boats getting, you know, overturned and everything. So it definitely has an impact. But yeah, if you have any, you know, personal experience on that, I'd love to hear it, because that would be really interesting. You know, any kind of tidbits like that are always cool to get for different areas that I don't get to surf as much as I maybe like to. Surfline used to have a swell angle window guides for areas on the East Coast. Where do we find these? From Meredith Madden. I'd have to dig those up if they're hidden down. We actually switched websites. We upgraded our website probably about 2 or 3 years ago now, and some of those tools that weren't used as much or were using some outdated source code kind of got pushed to the side a little bit, and that's definitely one of them that can be a big help to people. So let me see if I can dig that up, and I'll get your email and or I'll ask for your information. I'll see if I can find that information for you, and then also pass it along to others, because that's definitely a pretty cool tool to take a look at for your area. And I know on the old hurricane track that we had on the other website, there was that tool that I believe had Sebastian Inlet and Virginia Beach on it. So I'll circle back with you and get with you on that. Will you be adding more cams to the Northeast in Canada, and who hosts the cams and do you pay for them? Oh, great question, Meredith. Back to back. Yeah, we're always looking to expand our camera network, especially at locations that that people, surf. One of the big things that we've done over the past year and recently won a SEMA award for best new product is Surfline sessions. And that's pretty much where you can sync your iPhone with our app and our camera network, and it will actually automatically pull clips of your waves off our cams and deliver them to you by the time actually you pretty much dry off. We've had lots of people, places like Pipeline. You can do your session. I know Brett Barley's a big guy for there and for here. And by the time he comes in, those clips are edited and available for him. So we're always looking to expand our cams, and it's a delicate walk because you want to put them in places where people want them. A lot of places up in the Northeast and really everywhere, you kind of have a little bit of local sensitivity, and we're sensitive to that. So we don't want to go put it in some kind of secret spot and have everybody get really upset with us. So we're definitely on the lookout for locations, especially at breaks that are representative of other areas in that general area, and then also are popular spots. So we're definitely always on the lookout, not only in the Northeastern U.S., but Canada. I think it'd be great to have some cameras up there, even if it just means I get to sit here and look at them and pretend and wish I was there. But yeah, that's a great question, and we are. And then who hosts the cams? So we have a variety of hosts. So we actually have deals with various park services, including California State Parks. We have agreements with local municipalities. So actually Killable Hills, where I live, we have a cam that we host for them. Rental homes, businesses, hotels, pretty much anything that has a good view of the surf. I think our Salt Creek cam over in California is actually is hosted by the Ritz. So we kind of work with a variety of people, and in some of the locations we do pay. Yep. A lot of times, the majority of the time, the equipment is ours, and we pay for pretty much everything for the cam host, and sometimes if the location's good enough, we will actually pay to have that location as well. And yeah, so if you know anyone, please let me know. Oh, wow. Okay. Yeah. This is a great one. So sometimes I've noticed there's a discrepancy between the mobile app surf forecast and the desktop. Which one is more accurate? We have this question a good amount, and they're really, obviously there's one right answer is really what it comes down to. I've talked to our science team about this, and if, the one product says one thing and the other product says the other thing, it does nothing but erode confidence in your product. So the correct answer is the forecaster. The forecaster is the most accurate. If one of us is doing a surf report or a forecast for your area, we always say that that's the final word. The model is there as guidance, and we take that information and then we use our expertise and our experience to fine tune that and actually come down with a single answer that is correct. So the best thing to do is to look at the actual forecaster's input on what to expect for your area, and that will be the most accurate. And we've actually done studies to say that we are an improvement over not only our own model, but WaveWatch 3 and some of the other available Swell models that are out there. That the human element does add a value to the product. Why is Tybee Island, Georgia, so inconsistent? That's a great question, and it ties back into somewhat of the continental shelf question of, there's a pretty large shelf that occurs right off the coast there. Tybee Island doesn't have the best exposure to northeasterly swells, and you're not really getting anything out of the south, so it kind of limits the amount of directions that you can get swell from, and hence the amount of rideable days you have. I know in South Carolina and some areas there, you can get really tidal too. If you get, lower tides can be pretty bad or drained out. And yeah, it's just not the best swell window. And then the offshore bathymetry is just not all that favorable for you for the coast of Georgia, unfortunately. Oh man, these questions keep coming. Okay. I love it. When you say waist adjust tide, you mean sitting on your board or standing? That's another great question. Yeah, so the wave height scale is probably one of the hardest things that we do, because if you sit out in the lineup and you ask somebody, how big was that wave that just went by or that I just rode? you'll probably get as many answers as you have people in the lineup. So one of the things that we've done is we've tried to standardize that as best we can. You know, I mean, like I said, we're a global company, and what someone in Virginia Beach or Georgia or Florida calls chest high, someone in California or Hawaii or Australia may call it, you know, knee high. So we try to standardize that across all of our platforms, and we basically use a wave height scale with the idea that a surfer would be standing in a somewhat athletic position and a head high wave would be 5 feet. So we say that 1 foot is basically knee high, 2 feet is thigh high, 3 feet is waist high, 4 feet is in the chest high range, and then head high is 5 feet. 6 feet would be a foot overhead, and so on and so forth. So a 3 to 4 foot wave on the Surfline scale would be waist to chest high on a person that's basically standing on the wave. Is how we come up to it. But man, there's actually been a lot of research on, you know, the Hawaiian scale is something you hear a good amount about, and there's been some research by a person named Pat Caldwell who does forecasting for the National Weather Service out of Honolulu, and he did a historical comparison of basically the wave height scale of Hawaii versus the standard wave face scale. So there's been a good amount of research and discussion on it, and there's really not a great answer unless you communicate it clearly. So it's always a weird thing. You always feel like there's someone that tries to say it's a little bit smaller than it is and that sort of thing. But we try to standardize that as much as we can. Oh, on Long Island, how much sideshore wind is too much? That's a great question, not only for Long Island, but for everywhere. And you know, that's a good question. So a lot of it could go back to kind of the scale that's used to measure your winds. And it seems like if you're looking at a full-on sideshore wind, if you get much more than 10 miles an hour, you're really starting to contribute a good amount of chop and texture and kind of chatter up on the face if you're looking at a sideshore wind. But again, it also depends on your nearby environment. You know, a lot of times at Surfline, we mentioned like the north side of a jetty or you know, the east side or what have you. We'll offer a little bit more protection from the wind than if you were just some open beach break. And I know in Long Island, you know, the westerly wind thing or the west-northwest wind, it can play a major. I mean, the difference between it being just a little north and straight west is just a make or break there for certain spots. But I would think if you get much more than 10 miles an hour is when you're really going to start to feel that impact. Yeah, that's a great question up there because, gosh, you know, you have the opportunity to drive to Jersey if it's more westerly or vice versa. So that's a great question. Which buoys are best for New Hampshire and Maine? There's a couple, you know, there's, let's see, it's 44018. I think it's the Southeast Cape Cod buoy, but it's now actually just a little bit north of Cape Cod. Nantucket's a good one. Jeffrey's Ledge, which is 44098. There's a couple in the Gulf of Maine that are pretty good, you know, for you in that close environment. Easterly swells, you'd be looking out like Nantucket, Georges Bank, which is 44011. And then there's a couple of Canadian buoys that are further out, more over south of Newfoundland and Nova Scotia, that would be good indicators on easterly swells if you're looking at those for New Hampshire and Maine. Will global warming have a positive or negative effect on swell activity on the East Coast? This is Jason from what is it, North Central Florida. That's another great question. And we've actually done a little bit of research on historical trends of wave heights, and we found that actually since the 1970s, there's been overall a global decrease in the average wave height for many key locations across the globe. One of the locations that actually bucked that trend was New Jersey, of all places. So the long and short of it is the answer is still up in the air, and how that would impact, you know, whether you would have stronger significant systems or more systems or what have you. You have a global change in your actual temperatures that would impact, like we started off with here, if you change where your temperature gradient is, that impacts your jet stream, it impacts your storm motions, it impacts a wide range of things that can actually help or hurt different regions depending on exactly how it all ends up playing out. So it's definitely murky as far as, I wish I could be, oh, it's gonna, it's gonna be much better. But I think some areas will end up benefiting, and some may actually end up getting the short end of the stick a little bit if we continue to warm. All right, if you wanted to study this in school to pursue a professional career in marine water forecasting, what course would you pursue first to begin this knowledge? I would say math. The shortest answer is probably math, because when it comes to anything that we do as far as marine forecasting or weather forecasting, a lot of it is based in physics and math. And in order to understand some of the complexities of the atmosphere and the amount of work that goes into modeling that complexity, having a math-based background and foundation is incredibly important. So I would suggest trying to do that, and then any kind of environmental science or oceanography or any kind of thing that involves the ocean environment is always a plus. But I think the math is the real foundation. It's hard, but it's challenging, but that's where a lot of it starts. See, what are the best longboarding conditions in the Charleston, South Carolina area? I actually spent some time down in Charleston. I have my godson lives in James Island, so I go down there and visit my buddy and his family, and spend a little bit of time out on Old Folly. So it kind of depends on the swell direction, to be honest. Obviously, there's a tidal situation there. In South Carolina, you typically like your mid and higher tides if everything else is kind of the same. You get a decent east or northeast swell, and the south side of the pier. There's usually some pretty nice long little lefts coming off the south side. That's pretty fun. Tends to get a couple people on it. So, but there's plenty of room if you don't want to surf the washout, which is typically kind of a little bit of a more of a, I guess, performance wave as far as that zone is concerned. I've had some luck even a little further north up there, but I would target the mid and incoming tides to try to get a few waves if I was there. And then a lot of times, especially as we head into the summer months, you're going to want to try to find that along with the morning, because that sea breeze definitely kicks in there pretty good. And you get a southwest sea breeze or a south wind there, and a lot of times a little bit of swell that you do have will get blown out pretty quickly. So my advice would be try to find those mornings when you have a mid to incoming tide, and when the winds are still pretty light. How does the shelf affect your break? This is from Mario in Central Florida. So for us personally here on the Outer Banks, we see a little less decay than what we see in other locations, and a good amount of the time that's actually okay. Like, the East Coast has the reputation of being a small wave zone, and a lot of times, being able to eke out a waist-high wave is enough to keep you happy, especially during the summer months. But sometimes it can actually hurt us. I actually just did a story on First Street in Virginia Beach, the jetty there. What I call, we call it the best day of the century, which is a little bit of hyperbole, but we went back we have a record of our surf reports that goes back into the early 2000s for many locations, and even further back than that for some spots. And I look back at the best days that we've had there over the past 10 to 15 years or so. And it was really interesting to look at, because actually the best days in Virginia Beach are when it's too big here. So the day that we actually highlighted was, I believe, March 28th, 2018. And it was pretty good for Virginia Beach. It was actually really good for Virginia Beach, having grown up there. And it was actually just too big and out of control, outer sandbar. And in March, when the water's in the low 40s and it's 10 feet or whatever, breaking out twice the distance from the pier, it's not like you want to go out there and just start taking them on the head. So surf here was actually not very good, but it was one of the best days of the year, and actually the best days of recent memory up in Virginia Beach. So the shelf at times can actually kind of play to our benefit, where it doesn't decay our swell too much, so it actually keeps us in that rideable range, but other times kind of wish we had it a little more because we can kind of get a little too big sometimes for it to be really manageable. Unless you're Brett Barley, and then he just paddles out and gets barrels. So here we go. So this is Fletcher from Southern North Carolina. So why does Swell Info pick up short period swell better and Magic Seaweed pick up longer period swell better? Okay. So let's see. So Magic Seaweed, like I was mentioning earlier, is actually part of the Surfline umbrella of companies. And yeah, I would have to look at it. I mean, I would think Magic Seaweed is driven by the latest version of the publicly available WaveWatch 3 swell model that is also done with a little bit of tweaking behind the scenes by our science team, like Ben Freeston, who's the founder of Magic Seaweed and now works for us with Surfline. And then Swell Info, I know they, I'm not sure exactly what their model they're running. So it may just be that that Swell Info has a little bit better handle on the amount of wind swell that's being generated here right up along the coastline. But that's interesting. It's good to know because I combine that with the input from Beth that we got before this, and really shows that we really need to concentrate on the Southern North Carolina zone and really try to hone in our forecasting there, not only by the humans but also our modeling. So I will lock the science team into a room and tell them that they need to get that figured out before our summer surf season here really gets started. But that's great feedback, Fletcher. Thank you. And I would say that it seems like the model resolution maybe has something to do with it, but I'll try to get to the bottom of it. Can we get a cam at Cape Lookout? And probably falls back into the sensitivity thing. And I'm not off the top of my head. We probably have to go with the national parks and get something on one of their buildings or something like that. So there's a lot of loopholes that would have to happen, and I'm not sure that anyone would really want us to succeed. It'd be one of those cams you wanted to have just for yourself and not actually have on Surfline. But we're constantly looking for new cams in new areas, and like I was mentioning earlier, it's finding the right combination of a willing cam host that's able to work with us at a location that shows a break that is a popular spot and also not localized. So you kind of have to dance that line a little bit. Surfline does own Fish Track. That is correct. We actually own Fish Track, Buoy Weather, Surfline, Magic Seaweed, and then we recently acquired Coastal Watch, which is a company based out of Australia. Can you explain the recent shark issues on Cape Cod, and do you see this becoming an issue in New Hampshire and Maine? And do the great whites actually leave in the winter if the seals are still here? And so that's a great question, and I don't have much that I could intelligently say about it. I've read a good deal, and I know there's that what is it, Ocean Search that does the tracking of the great whites and that sort of thing. I would think that they'd probably be a great resource for checking out the migratory patterns of the great whites and that sort of thing. But I know that for the fear that there is of them, and there's not a lot of research that's done on the whole life cycle with the great white, and I know there's been an increase in interactions along Cape Cod, and I don't know too well if that's related to some sort of predator-prey relationship where there's now there's more seals or anything like that. But yeah, I don't know. I would probably default to what they have to say because they've definitely been studying it way more than I've had a chance to. In my opinion, was the best wave height for shortboarders? That's a great question, Caitlin. And I think it varies from user to user and experience level and kind of what you're looking for. We've actually done a little bit of research that goes into what our users think is a good wave. A lot of times, the idea is that a big wave that's all offshore wind is going to be great, but that's not necessarily the case. And we found that the average user likes a wave somewhere between the chest to head high to a foot or so overhead range, and that's kind of where the intersection of being comfortable in surfing and your ability and actually having fun surfing waves of that size actually kind of crosses, and that's kind of the main zone there. That's really the meat of that. And I would tend to echo that. You know, I think something in the head high range is still pretty fun and playful. You can get barreled and, you know, all those other things. A couple feet overhead, obviously, to me, still good. You get much bigger than that, and it really depends on kind of where you are. You know, if you're surfing a point break, to me, it's, yeah, I mean, let's get it a little bit bigger. But if we're, you know, dodging closeouts and trying to pick a corner out at a beach break in the middle of winter, I think I'd rather have it just be about head high. But I think it's kind of to each their own. And again, it's back to an experience and also kind of what kind of break you're surfing. How many people contribute to Long Island reports and forecasting from New York to Montauk? Does one compile info for publication? Yes, Noah. So the way that we do this is a lot of times we will have one person that we call basically a coordinator. So it'll be myself, or a lot of times up there, it's Rick, who's based out of New Jersey, that does those reports. We do have a member of our team up on Long Island. He lives out, let's see, he's a captain, and he does stuff with out towards Fire Island. And he'll send us reports and everything that go along to mix with Rick's observations and our cameras and the buoys to kind of help compile all that information into generating our reports. And then the forecasting of things, you know, a lot of times it's myself or Rob Mitzcipher. They're looking at the various swell models and weather models and compiling that information and breaking it down into our two zones, which is pretty much Suffolk County and then Nassau and Queens County, to come up with those colored boxes and stuff that we chatted about earlier. So it's kind of a collaborative deal between the observations that we can get on the ground, our cameras, the buoys, and then our own personal experience up there. I have to come visit you though. I want to go surf up there again. What is the best swell in degrees, the best swell angle in degrees for a tropical swell to reach the boat banks? Beth, thank you for the question. Pretty much, I would think what you would ideally want, I mean, a scenario where you got a straight south wouldn't be the worst, because, you know, if you're looking at a longer period swell and you get too much of an east out of it, a lot of times you can get those drifty lefts that kind of come through, and you know, you'd be paddling against a little bit of current. So something with a little bit of a southerly direction, but maybe a little bit of a tilt to it. So let's give it how about a 165? So kind of a south-southeast, and then some light northwesterly winds. Probably be a pretty good combination there for you. But there used to be a spot that used to handle a lot of different things there, but we won't talk about that. Can you discuss the swell timeline on the Surfline app that shows different swells at different heights at one time? Yes, I can actually pull up that here. It's also on the Surfline web page here, and I'll pull up my app too, just to make sure that we're seeing the same thing. So pretty much what we've done here is we've broken down the individual swells that are impacting our surf, that are going to be in the water that could impact our waves here going through the next 17 days. So as we were looking at Rob's forecast earlier, so this is actually a little bit of northeast wind swell. You can see, if we mouse over here, you can see the northeast swell at 46 degrees. The plus or minus 8 is actually a range of swells. So the swell does not necessarily come in at one specific degree angle. There's a lot of times there's a range, and that range is kind of dependent on several different factors, including the distance away that the fetch is, and a couple other different things. And then we give a reading of feet and height of that individual swell. So there's also a little bit of residual southerly swell that's actually from the system that pushed off today, a little bit longer, 9-second energy. And then that southerly direction. So if I'm looking at the northern outer banks and I see a 1.6 at 9 out of the south at 172 degrees, not going to be a major impact on the actual swell for us here because of the way our coastline faces. But the key here is basically it's every swell that's out there that could potentially impact what your surf is going to be like, and what is in the water. So as we go further out here, you can see there's a couple little southerly swells that are going to be impacting us. If we look at Friday, it has getting up to 9.4 feet at 8 seconds, again, out of that south-southeast direction. Not a lot of that's going to really make it to the coast, and that's why Rob's only predicting waist to stomach high surf. So we interpret that information into like I said, those colored boxes. If this was a different direction, if it was 9.4 feet at 8 seconds out of the northeast, it would be 8 feet. So 6 to 8 feet probably. So it plays a big role, the direction, and what we do is we interpret that information and then come to a conclusion on the colored boxes. Let's see, what's the biggest factor that affects waves at Folly Beach, South Carolina? I would think there's, in addition to there's a couple different things. The offshore continental shelf, but that's always there, so that's something that you're going to deal with. Your swell direction is always big in Folly Beach. The northeast wind swells that will go down and can produce some pretty solid surf down in the Florida. A lot of times will bypass you and kind of sweep down the beach, and you don't really get that much size that come in. So swell direction can play a major role. Period is also a big one because you can have some fluctuations in size depending on the tide and that sort of thing. Because a lot of that energy is decayed further off the coast when you have that longer period energy. And then let's see what else affects. Oh, definitely the tides. I feel like the tide is probably one of the biggest factors down there in Folly. So great question. I think, do I have more questions? Are we good?
I think you're good.
Okay, I can take a breath.
Actually,
Period.
I stopped everybody from asking them.
Oh, did you?
I just said, that's a lot. So we'll definitely have to do this again and have more question and answers, because it sounds like
I'll stop my share here.
A lot of people have a lot of questions, and good questions too.
Yeah, they're great questions. There's so much to talk about. Especially when you're looking at, the whole, we just touched on some East Coast locations, but you expand that out to the Caribbean and, worldwide. And yeah, it's, there's a lot of stuff out there that we can talk about. And I love talking about it. So you probably could have kept me going.
Well, we would love to have you back.
Oh, definitely.
We would love to do this again. We would love to do this several times because I think it's a great resource for our members, and there's just so much information out there, and I know it's confusing for a lot of people. So I really appreciate the information that you gave everybody today, the basics. And I know you can elaborate on these basics. And boy, you do get excited about those buoys.
I really do. It tells you so much information. It's like, it's like getting it just tells you whether you're going to surf or not. And
it is. It's really, once you start understanding it, it really is. It's a useful tool. And I know we use it a lot around here too. Thank you for doing this, Kurt. We really, really appreciate it. Thank you, Surfline. Thank you to everybody who tuned in for our very first online course. It was only supposed to be an hour, but it just showed that everybody had a lot of information and you were giving very good information out. So thank you. Sorry to keep everybody, but I'm glad you guys were able to walk away with, knowing a lot more than you did before this started.
And I will say, if you have any other questions, my email is just it's my last name. So it's Korte, Korte @surfline.com. So if you have other questions or, any of the great feedback that we had, please don't hesitate to reach out, and I'll do everything I can to help.
Thank you. Thank you so much. All right, everybody, have a wonderful evening. Join us on Facebook Live tomorrow with Corey Lopez and YouTube Live, ESA's YouTube channel. And then on Wednesday, we'll be back with Chris Mills for surf strength coaching training to teach us what we should be doing while we're at home waiting to be able to go surf again. All right, everybody, have a wonderful evening. Kurt, I hope you catch some surf tomorrow down there in the Outer Banks. Catch a few waves for us, and we'll talk soon.
I'll do it. Appreciate it.
Thank you.